Hi friends, I would like to begin today's session by discussing a simple question: why artificial intelligence and machine learning needed? To answer this, humans especially don't have the knowledge to program every possible event or circumstances. We simply cannot anticipate every permutation and combinations. That is why we build AI systems, or to gain knowledge that we may not have. So, artificial intelligence and machine learning can very quickly determine the best possible or the best available decision based on the various algorithm and used to analyze various states. The world of artificial intelligence include many areas in computing, which makes it a complex field. In this video, we will explore applications, techniques, environments, and behaviors of artificial intelligence and machine learning. You might be surprised at the number of disciplines, fields that have active involvement in artificial intelligence, like philosophy, which assists in deciding how can the thought process be defined in a series of steps or rules that can be programmed. Then we have psychology, that is keenly interested in determining how creatures, humans, and other animals forms thought processes and actions from the thought processes. Then we have economics, which concerns itself with determining the best way to make decisions in order to maximize the benefit and how to act independently or jointly with others. Then we have mathematics, which focuses on turning decision processes into rules and computations that will result in accurate results. It also deals with uncertainty, a tricky issue that presents a significant problem in the creation of AI. Then we have computer engineering, which focuses on artificial intelligence from building the actual machine. We also have neuroscience, which helps to understand how a human brain accepts, processes, and reacts to stimuli on a neurological level. Then we have linguistics. It is keenly interested in how language is compiled, processed, and understood. So these all are the fields that plays active role in AI, artificial intelligence, and machine learning. Now let's see few examples of applications of artificial intelligence, like voice interface, Alexa, Siri, Cortana, and Google's voice activated artificial intelligence are popular and quickly growing applications of artificial intelligence, allowing users to ask questions and engage with computer intelligence. Then we have robotics is another popular application of AI, with robots being used either to automate process like in manufacturing facilities or to work in hazardous situations such as collapsed building or bomb scares. Other common applications of AI include linguistics, planning, determining the best use of resources and routes. For example, utilizing mapping system in along with the GPS to determine the best routes for delivery trucks, identifying construction zones or traffic jam and rerouting. So, developing an intelligent machine or a system involves deep understanding of environments and concept of intelligent agent. So, proper awareness of intelligent agent and environment that agent will work in is essential and is crucial in designing and implementation of AI and machine learning. Just to recall, in our last video, we understood what the agent is. So I'll just repeat, intelligent agent are any mechanism that wait for a condition or a series of conditions to be met. And when that happens, agent act upon an environment. For example, a thermostat will activate heat when it senses that the temperature has dropped below a set level. In the field of AI, the sensor is referred to as a receiver or percept, and the mechanism that provides the action is called an actuator. An actuator is a component of a machine that is responsible for moving and controlling the mechanism of system. And the code that maps the relationship between the percept and actuator is called an agent program. In simple programming terms, there is an input to the percept and an output to the actuator, with the program in the middle determining whether the conditions have been met and whether to activate the actuator. So now come to the concept of type of intelligent agent. First we have simple reflex agents. As the name suggests, it is simple in the fact that the simplest of the agent. Simple reflex agent only use the current state of the environment. In other words, they don't care about past states or any history that might provide a pattern. Example of a thermostat is a good example of a simple reflex agent. Next we have model-based agents, which require more information to function. They use external inputs from the environment, but before actuating also depends on a set of rules or observations as well as an understanding of past actions, a history of previous actuator, and the results. For example, a speech recognition system that understands English. The agent gradually learn to better understand the user's voice command. Then we have goal-based agents. They use goals to determine the result of certain actions and take into account what happens in the future. For example, a GPS system, which can create a route to get a driver from point A to point B. Goal-based agent uses its former action combined with goals to make its decision. Then we have utility-based agents, which go further in the decision-making process by considering best choices. So you can see the agent can probe here, like how happy will the user be with the decision. That's the utility, a measure that speaks to quality of the decision. For example, a GPS system can create a route to get a driver from point A to point B. But what determines the best route? Sometimes the shortest route by the distance isn't the best route. Perhaps there is a traffic jam or road constructions. What is the meaning of the best possible route? The shortest by the distance, the shortest by time, the safest one? Are you driving or walking? Or we can say agent strives to determine how the state will be achieved in the context of need. Then last we have learning agents. The ultimate goal of artificial intelligence should be to build rational systems that learn and self-improve. Learning has ability to use past actions as a way of improving new actions. So the learning agent is a popular model that is frequently used in modern AI design. And it is advantageous because agent here doesn't require a prior knowledge in order to function. Agent learns a better way of doing things through the learning elements, which interacts closely with the performance element, which chooses the actions. Now we will deep dive into the concept of task environments in which intelligent agents live. Intelligent agents are only intelligent in the context of their environment and the task that they need to perform. The task environment can be broken into four categories, which is known as PEAS, that is, performance, environment, actuator, and sensors. And these all have to be properly populated to design an intelligent agent. So let's take performance. For agent, performance means this is the measure and goal of the agent. For example, in chess game, there are two basic conditions for continuing or ending a chess game. First, have I won it? And do I still have my king? Meaning I haven't lost. And a third measure, whether we have a draw match. Now, what is environment for an agent? It is the external environment that the agent will be interacting with and acting upon. Understand it in context of chess game, wherein you have a chessboard and pieces, a game clock, and of course an opponent. Now let's understand the concept of actuator in terms of agent. Actuators, the mechanism that performs action on the external environment. We can understand it in the context of chess game. It is the way to move the pieces. Sensors, the input needed in order to understand the external environment. So if we understand it in the context of chess game, we can say a camera can act as a sensor so that agent can see it like chessboard and its pieces. Let's understand the concept of an observable, a partially observable, and an unobservable environment and describe how these affect agents. In observable environment, however, an agent sees everything in the environment at all times. The agent doesn't need any information other than what it can immediately observe. In the example of a chess match, the chess playing agent needs to see the board and all the pieces, both of the agent and its opponent. And we can take example of image analysis, where an agent need to be able to see an image in order to analyze. If the agent's task is to digitize a face from a printed photograph and the face on the photograph is partially hidden because there is a book sitting on the half of the face, the agent is not working in an observable environment. In partially observable environments, agent can only see parts of the environment, like the example of the photo half covered by a book. In such an environment, an agent must build a mental model. For example, understanding the shape of an entire face, the shape of a mouth, that there are two eyes and two nostrils, and so on. In such a scenario, it might be possible for the agent to reliably construct the face with only half the information. We can take the example of Mars rover, which needs to navigate a terrain but can only observe part of the terrain. Then let's come to the concept of unobservable environments. These are, as the name suggests, completely unavailable to an agent. The agent has no information about the environment, perhaps because it has no sensors to detect the environment. Or we can understand it in a way like suppose there is a heavy storm where there is a zero visibility. Now I'll discuss how the number of agents in a given environment can affect the problem solving process. So first we have a single agent environment wherein agent must perform its task by itself and only consider the task at hand. So as an example of this would be an agent tasked with solving Sudoku puzzles. Now let's talk about multi-agent environment. Here agents must work with other agents to achieve their goals. For example, self-driving cars that have to interact with other cars that act as agents. Even if those other cars are not intelligent agents, they still act as them because they move, they change lanes, and an intelligent agent must, by its programming, navigate safely on a road. And all other cars need to do the same, driven by humans or not. Another example we can take for multi-agent environment is a soccer match wherein cooperative multi-agent environment with every player on the field acting as an agent that needs to work with others. Then we have competitive multi-agent environments. These are the environments where there are many agents working in a natural competitive environments, meaning that the agents are encouraged to perform better than other agents. Simply, we can understand it, there are rewards or benefit for performing better. We can take example of soccer match of a competitive environment because every player benefits from being more effective than the others. Now let's discuss about the certainty in an environment and how the level of certainty in an environment affects agents. So first we have stochastic environments. These are the environment with the level of uncertainty or chances, if you will. Example of stochastic environment include dice game, where there is no certainty over how a roll of dice will result. Or another example of stochastic environments we can understand by a self-driving car because they don't know what is around the corner and the environment of a highway filled with the car is naturally chaotic, changing constantly in unpredictable ways. Then we have a deterministic environment where agents have complete control over the environment's outcomes. Because there are no variables, everything is fixed. Like image analysis, which is a good example of a deterministic environment where the agent can see an image in its entirety. There is no uncertainty, at least in the context of the pixel being processed. Developing intelligent agents involves working with environments. When we talk about environments behavior, there are ways that we can generalize and categorize agents behavior or environment behavior, and this allows us to choose the right agent for the job. In episodic environments, states are not connected and there is no consideration given to the other states. For example, image analysis is also episodic because when an image analysis agent is analyzing a single image, it is not thinking about the image before it or the one after it. Action undertaken by an agent only affect individual state or episode, which is why we refer to this as episodic states. And second, we have sequential environments. In sequential environments, there is a connection between states, with the states affecting others. Actions need to be planned for a sequence, relying on the other states during processing. Example of this environment, we can take a chess game where strategy is critical. A chess playing agent not only has to consider its own move, both past and future, but also the moves of its opponent, the sequence, the strategy. Or we can understand sequential environment behavior by taking example of self-driving cars, which also have a sequential environment to deal with. And then we have a static environment behavior. The environment doesn't change while an agent makes its decision, reducing the need to make quick decisions. We can understand static environment behavior with an example of a chess match where there was no game clock or solving a puzzle that doesn't have a time-based limit. So here environment doesn't change while an agent makes a decision, reducing the need to make the quick decisions. Then we have a dynamic environment behavior. On the other hand, the environment changes while agents make decisions, meaning that they have to continuously make decisions, often changing their decisions on the real-time based on the external environment. Good examples of this are self-driving cars, which have to constantly review the environment and reacts. Other examples like video games, where situation changes based on the action of the player. We also have a semi-dynamic environments behavior. We can say it's a kind of static environments where performance changes over time. We can understand it by an example of a chess where chess with a clock where an agent has a limit amount of time to make a move. Or we can take other examples like puzzle solvings where speed is often a metric by which you are graded. And at the last we have a discrete and continuous environments. So in discrete environment, there is a finite number of states and actions. So actions will move states to different states instantly. Example, like chess with a clock, because in this example, there is a predefined number of outcomes and moves are constant and determine gameplay. In continuous state, on the other hand, there is an infinite number of states between states. Action are continuous throughout states. As you might have already guessed, self-driving car are a good example of continuous states. For one reason, because steering is a continuous process of driving over many states, like changing lanes, accelerating, braking, turning, passing, being passed, and so on. So this was the deep understanding of artificial intelligence applications, techniques, environments, and behaviors. In my next video of the series, we will move further, know more about other concepts and tools of artificial intelligence and machine learning. Hope you liked the video. Please like, share, and subscribe this channel for keep enriching your knowledge. Thank you and see you in the next video. Bye-bye.